Today's NUS Greater Good series has been brought to you by the NUS Development Office. The series, which has been made possible by the generous support of Newsman Realty Private Limited, aims to raise awareness of philanthropy and its impact on society, with a focus particularly on Asia. We achieve our aims through outreach activities such as talks, conferences, and forums by eminent leaders, education and research to promote development, service, excellence in NUS, and program initiatives to advance the philanthropic interests of NUS. Now it is my pleasure to introduce Professor Prakash Kumar from the Department of Biological Sciences at NUS to give us an overview about today's topic and introduce later our speaker, Mr. Kailash Murthy. Professor Kumar, please.
Good evening, everyone, and I thank you all for giving me this opportunity to address you after the dinner, but before the guest of honor speaks. So it is indeed a privilege, and I'm not going to take that long, but I did prepare a few slides. So it so happened that when Holman and Mr. Wee invited me, asked me to see if I could chair the session because I'm doing something related to plants, plant biology, and we do some work on some selected food crops, specifically rice. So I did alert him that we are not really against modern technologies. In fact, it's quite the opposite. We do use modern technologies. But then I will highlight to you my viewpoint, and then I will point out that alternatives are always good to have. Okay, so the importance of rice as a food crop, I don't think I need to stress too much for this audience. Asians in general, or those who have lived in Asia, will know that it forms a staple food for something like half of humanity. About 4 billion people in the world are dependent on rice as a staple food. And what you probably have not thought about or not paid attention to is the vast land area it occupies. In Southeast Asia alone, about 600,000 square kilometers of land area is used for rice growing. Right? And this excludes another 1 million that is in the two neighboring giants, China and India. So if you put all together, the table at the bottom will show you the world area used for rice cultivation is something like 158 million hectares. Right? It's about 1.58 million kilometers square area. And we produce about 700 million tons of rough rice, and once it's polished, it's close to 500 million tons. Right. So the grain yield, you have heard from so many sources now, and it's become, after hearing it so many times, it's become accepted, not just because you've heard it so many times repeated, but people have realized that the global climate change does have an effect on crop yield. So there are several key challenges that we face for rice cultivation. What are some of the things that we need to do? I mean, obviously, this is not an exhaustive list, but this gives you some idea about what one could do. Utilizing technology, what can one do? Right? You can make rice suitable for the changing environment. You need to ensure the yield stability, and you need to develop probably new crop management technologies and things like that. I'll make a case for it later on. Right? So it is not contested anymore that you need to increase the crop yield to ensure food security for the growing billions of human population on the planet, right? So should we use high technology? And this has been the topic of conversation around the dinner table, I'm sure around your tables as well. Should we stick to just organic farming, or should we use high technology? So I hope that some of the points that I use in the next several slides, I will not be using more than another 5-6 minutes, I will try to convince you that an alternative is good to consider, good to have as food security, right? So in terms of should we use high technology, I would like to take the liberty to use an example that's probably easier for you to understand. And by no means, I'm not advocating this as the food security alternative for the world, but we all know that breastfeeding is the best nutritional option for infants, right? No dispute. We all recognize that. But what do? We have developed such a huge industry for baby food. The baby food industry has crossed like $14 billion per year. Right? And what does it involve? About 50 to 70%, depending on the estimate you look at. 50 to 70% of it goes for infant formula. We have a beautiful logo to advocate breastfeeding, but then out of convenience, we use this technology. It's not, mind you, it's not high-tech genetic modification, none of that, but it is a simple but an alternative technology. So, when we all acknowledge that breastfeeding is the best option, we do resort to technology for our convenience. That is modern society. So, developing modern technologies for crop improvement, likewise, is, to ensure food security, it's a wise option to follow. That's my pitch. Anyway, so the other point that I want to highlight is just like with infant food, no one disputes that breastfeeding is the best option, but alternatives are used. So the same way, utilizing high technology has or should not put the technological advanced commercial farming in any conflict with traditional or organic farming. It is an alternative to be used. Okay, so what do we do here at the NUS, Department of Biological Sciences? When you see DBS there, we're the poorer cousins of the DBS Bank. It stands for the Department of Biological Sciences, and TLL is the Temasek Life Sciences Laboratory. We have, between the two establishments, we have more than 20 research groups that are focusing on various aspects of plant biology research, different aspects, right? One of my colleagues is sitting there, Sanjay. So he's one of the 15 that I've counted, by the way. So our interests are quite diverse. We use developmental biology, genetics, molecular aspects, physiology, and we have colleagues who look at ecology, the wholeness of it, ecosystem, the implications of ecosystem, or the modern practices on ecosystem, etc. So I just want to switch slightly over to another topic I want to introduce, water and rice. Well, what is the relationship between the two? Again, most of you, or I hope most of you are familiar that rice crop requires plenty of water. How much water does it require? For the 700 million tons of rice that we grow, it requires about 1,750 kilometer cube of water per year. What's a kilometer cube? I know a liter of water. It's about 1 kilometer cube is equivalent to 1,000 billion liters, right? That's 10 to the power of 12 liters of water. Okay, how did I get all this number? Well, IRI, or the International Rice Research Institute, we collaborate with them. They have all these statistics on their website. Okay, so the table down there, I should be able to use the pointer. Yeah. So here, it highlights for rice, it's about 2,500 liters per kilogram. This is more manageable numbers for us to visualize. And for, if you took other grains, the three major grains being rice, wheat, and corn, on the average, about 2,000 liters per kilogram of grain is used. And that's in normal land. But if it is arid climate, dry climate, you need much, much higher amount of water per. I'm not going to be very popular with our PUB when I share this statistic with you. The water used for domestic use worldwide is only a tiny, tiny little fraction of what's used for food production. Right? So the bulk of water used in the world today goes for food production, agriculture and raising farm animals and so on. Right? About 80% of the water use. Well, so quite a large amount of this in the region apparently is lost due to inefficient agricultural practices and using plants or crop plants that are not very efficient in water use and fertilizer use. So you need to develop better plants using technology. Now, because I pointed out, because it is such a water-intensive crop, now the flooded rice fields are the region's most extensive wetland ecosystem. Most people don't look at it as an ecosystem. It's a paddy field, but it is a habitat. It provides a habitat or living space for birds, small mammals, fish, frogs, insects, and so on. Right? So, but then what do we do with this field? You will hear from the invited speaker today that we dump hundreds of millions of kilograms or tons, in fact, of pesticides and agrochemicals, fertilizers. This is commercial farming for you, right? We dump that, and it goes into the biodiversity, into the ecosystem. It's in there. We dump it there, and then, well, we can't take it back. It goes into flows to the rivers and then to the bays. And when China wanted to conduct the Olympic sailing, they had to mobilize a huge army platoon to go and clean up the bay because there's algae growing there. That's because all is runoff there. So the action needed, some of us have identified a few major actions needed. Well, you need to study the effect of all these pesticides on and agrochemicals on the ecosystem, devise a mitigation plan. Right? We can't do away with technology completely, but so we need to try and minimize that. This is another statistic I wanted to share with you. Rice fields are a major source of greenhouse gas emission. Again, I can see people nodding there, and some are wondering, well, it's not rice plant that is the culprit. About 15% of global methane emission comes from the rice fields. It is from the bacteria that grow along the root surface of the rice plants. They thrive in this anaerobic or low oxygen environment when you flood the rice fields, right? So my colleague Sanjay Swarup looks at this aspect as well, right? So we need to study this and try to devise ways of mitigating this, right? So what do we plan on doing with this? We have identified a few big problems. What do we plan? We plan to establish a small rice research center over at NUS in partnership with TLL and IRI, which is the International Rice Research Institute. They're located in the Philippines, but it's an international institute. This will help us to pool the expertise to come up with a truly multidisciplinary approach to study these problems, these big problems, right? Again, the other aspect that we want to do, and also IRI's mandate, is to have regional manpower training and education. So this will help us to create exciting new knowledge, besides establishing world-class collaboration, and we will have impact across Asia because IRI already has a very good setup with the grassroots farmers in the region. Well, we need to raise funds for it, but we are not sitting idly while waiting for it. We were able to get a major research program grant, 4 groups from DBS, my department, and 4 groups from TLL teamed up, and we were successful in getting generous funding from the National Research Foundation in the form of a competitive research program, 10 million over 5 years. So the idea behind this project is summed up in the title that is down there, Rice for the Future. Novel strategies to develop elite and improved varieties for sustainable rice production. Just one slide to sum the details up. So we have 3 sub-project ideas, if you like. So the first one is to look at disease resistance aspects. Now, the invited speaker is going to suggest some alternatives for this as well, right? And allow the plants or develop the plants to be able to tolerate more of the stresses like drought, water use efficiency, that's the point I was making earlier, and nutrient use efficiency, so you need to dump less fertilizers, right? And thirdly, we want to get the varieties that will have better seedling vigor, better growth vigor. Again, the speaker will tell you that when you have vigorously growing healthy plants, they are not going to be attacked by diseases and so on. So that's in line with that, and this is what I'm trying to convince you. So my last slide to sum up, we have some perspective about the future for rice research and how we can participate in this. When new initiatives for rice research are necessary to address future food security. That is our pitch. And we need to employ a multidisciplinary approach for this, right? And we should benefit from technology. We shouldn't shy away from technology, whether it's high-tech or low-tech, whichever, new technology and alternatives. We should benefit from that, right? But at the same time, this is again in the heart of the guest speaker's presentation, which you will be hearing shortly. So we should be mindful of the needs of the small rural communities that may be slower in adopting the high technology, right? And we need to provide alternatives for them, right? Now, I'm not speaking as an urban raised boy. I grew up in the rural area, not too far from where the guest comes from, about 200 kilometers away towards the coast, right? So we need to develop suitable alternative strategies as well. That's our pitch. Okay, so thank you for your attention for my brief presentation, and keep in mind the alternative views that we have presented, right? So it is not in conflict with what you will be hearing soon from the guest. Okay, so with that, I would like to switch over and give you a brief introduction about the speaker, today's speaker. Mr. Kailash Murthy used to be a banker by profession. He retired from that, from a successful banking career, and then he turned into a traditional farmer in a rural setup, village near Bangalore, and he will share the concept of zero farming. It is the exact opposite of what I've been trying to convince you. So this follows traditional methods, but he will tell you that there is no farming, right? But it is traditional. No cultivation, do not use any chemicals, no pesticides, no weeding, no production cost or very low production cost, right? All in order to reap bountiful harvests. So it's not like you settle for what you can get. That's not what he's trying to do. And it will maintain a strong respect for nature, for the system as a whole. It's a holistic approach. He's the founder of the Academy of Natural Farming in India, which educates the public on food sustainability and environmental integrity. Mr. Kailash Murthy.
It's my duty to say thanks several times for you people, because when I was studying in my college, I read in a paper, I wanted to visit Singapore as a visitor, to see beautiful city, the honest people and clean city and dedicated people. But now you people invited me to share my knowledge, that's why I must say thanks several times. So first of all, I am not a theoretical man, I am a practical man. But I did my graduation in my mother tongue, Kannada medium. So when I was studying in 8th standard, I was suffering from severe asthma, a chronic disease, when I was a 15-year-old. Then I left my studies for 3 years. I joined my parents with agricultural activity with my parents. Immediately my health improves like anything. My parent told me that again you can go for studies. From that day onwards, every day I used to go to college and play games. When I was in college, I became India number 2 in 800 meters. After retirement from my sports activity, I opted agriculture. Instead of going for stadium for jogging and playing games, I can work in my field to improve my health and as well as my food security. And then I can earn also. I started with chemical farming. So, in the year, since from 1984, from 77 to 84, I was representing my bank and my current state. Then after retirement from sports activity, so I started with chemical. So I will, since from 84 to 88, I was using chemicals and all sorts of pesticides recommended by our research institutions like Indian Council of Agriculture Research, University of Agriculture Science, Bangalore. So I have what all the instruction they have given to cultivate my crops. I was implemented in my farm, but I have failed immediately. Within 4 years, I came to know that I am doing wrong thing. So pest started resistant to all pesticides. Every year, I have forced to change pesticides. And then inputs keeps on increasing by 25%. So 1988 left all inputs and switch over to natural farming. The natural farming principles, the method adopted by Masanobu Fukuoka, a Japanese farmer. So I have taken two principles from him, that no pesticides and fertilizers. Other two concepts I have developed myself when I was doing chemical farming. So he is the man, he is the pioneer in natural farming, he is my teacher. So Mother Earth, do we have any right to damage it? So in the total universe, we are having living organisms in the earth only. There is no other organisms, there is no animals. So it is proved that we can find living organisms only in our planet. It is not our responsibility to preserve it for future generation. So what is happening farming? So 4 principles of natural farming: no fertilizers, no pesticides, no tillage and no weeding. Then what else? The only sunlight and less water. So when you are studying in 8th standard and 9th standard, plants produces food through photosynthesis. Whether I am right or wrong? So when we join our colleges like BSCAG, see, we will start using fertilizers and pesticides. See, actually our practices move all the 3 farmings: organic farming, chemical farming, then natural farming. I have a knowledge of all the 3 agriculture practices. When I was in college, school days, we are organic farmers. When I started chemical farming in the year 1984 to 88, from 88 to 90 till today, I am practicing natural farming. Okay. So benefits of natural farming: it's 100% natural friendly. We are not disturbing nature, even a %. So increases microbial activity. It's increased microbial activity. In chemical farming and organic farming, we are flowing the land, we are digging the land. See, we are finding animals in 3 places. One is aqua animals, the animals living inside the water, the animals living above the surface. We all belonging to animals group. The animals living inside the soil. It's very important. So here, suppose in natural farming, we are increasing the microbial activity in the soil. The excreta of the microbes is the nutrient for the plant. There is a symbiotic between the plant and animal. Animal excreta is the growth promoter of plant. Plant excreta is the growth promoter for animal. So we are inhaling carbon dioxide and then we are giving carbon dioxide. So what all the excretas, animal excreta is the growth promoter of plant. So without animal, plant cannot survive. Without plant, animal cannot survive. So this is the major principle of the natural farming. So soil structure improves. Automatically every year the natural farming soil structure keeps on increasing. I'll show you next slides. Nutrients available for the plant longer period. So suppose if we use chemicals, the soil fertility keeps on decreasing because we are killing the microbial activity in the soil by using chemicals. Like N, N is, it kills all the microbial activity in the soil, but I don't want to elaborate that one. Prevent soil erosion. You see, natural farming, 100% natural soil erosion will be checked because the microbial activity is more in the soil, so they will create porosities in the soil. So soil will be loosened. Suppose what all the rains we are getting, it percolates, it holds inside the soil thing. That's why the soil erosion is be zero. Free from accumulation of material hazards, accumulation of material hazards to the soil. We are not adding any chemicals. Okay. No chemicals residues are present in the crops because we are not using any pesticides and fertilizers. The food what we are growing is 100% chemically free. So crop resistant to pests and diseases. But I am going to ask you one question. If people can ask you, see, who came first? The pest came first or the plant came first? See, this is the answer. Without pest, plant cannot survive. Without plant, pest cannot survive. So we are pest for the paddy. At the same time, you are promoting and preserving and growing. See, what all the food we are consuming, we are pest. What all the animals we are eating, we are predators. At the same time, you are preserving and protecting and developing. Whether I am right or wrong. Harvested products are premium quality. The taste and keeping quality and everything is good. Production cost is very less. When I have used chemicals, the input will be more. Suppose production cost comes 1 rupee, 5 rupees per kg, like pesticides, fertilizers, fungicides, agriculture technology, using agriculture technology. So I am forced to sell my product at the rate of $10 per kg. If the production cost comes $1 with using only sunlight and less water, I can sell my product at the rate of $2 per kg. So automatically the production increases in natural farming. Mitigates global warming. I will show you in the next slides. It's 100% carbon sequestration will be more. What all the sunlight is, it will never reflect. Genetic stock is not affected. So in other farming, organic farming or chemical farming is a decentralized technology. The natural farming is natural farming is a decentralized technology. Chemical farming is a centralized technology. But it's controlled by few MNCs. Hazardous. Oh, it's here. So it's reverse. Many toxins are used in agri-criminology and agri-business. It's a criminology. When you kill a person, you will become a criminal. When you kill insects, you are not a criminal. When you kill microbes, you are not a criminal. So, in the name of food production, we are destroying all the flora and fauna. So, suppose if you cut a tree, you will become a criminal. And agri-business, in the form of fertilizers, pesticides, herbicides, rodenticides, fungicides, nematicides, etc., the food consumed by us is not free from these chemicals. The effect of these chemicals have reached dangerous level, causing health and environment damages, resulting in production cost up, reduced efficiency in food production, even loss of valuable human life and diversity. We are destroying all the diversity, including human beings, in future days. So effects of fertilizers and pesticides and tillage and weeding. Destroy soil organisms like bacteria, fungi, algae, protozoa, nematodes, insects, arachnids, mollusca, worms, mammals, etc. Flora family like Leguminaceae, Aranthaceae, Azioaceae, all families we are destroying by using weedicides and pesticides. See, I wanted to explain what all the major problem we are going to face very shortly. In my farm in the year 1964, water table is within 10 foot. So 1984 to 35, it's gone down to 35 foot. 1988, it's gone down to 100. 2012, there is no groundwater at all. So this is not is my problem. It's not my problem. It's the problem worldwide. So groundwater depletes abnormally, irreparably. So in future days, it will directly affects on food production. So chemically grown banana in the year 1987. I was using all sorts of pesticides and fertilizers to grow this banana in the year 1987 with more inputs. This is nothing but a cocktail pesticides food. With using all chemicals recommended by ICR people. So it's almost, such kind of a big bunches, I'm a commercial farmer like that, I left everything and then I switch over to natural farming. Suppose if I continue same farming, so I don't know what kind of food I used to grow for the society. Whether it's a cocktail, almost it's nothing but pesticide, pest and with more chemical residues. So ill effect of endosulfans. See, nowadays we are using a lot of chemicals and pesticides, especially a lot of pesticides in agriculture field. Knowingly, unknowingly, we are consuming more and more pesticides. So I am going to talk only on endosulfan. So the symptoms started. See, this endosulfan used in near very close to very Prakash place. So only endosulfan they have used about 10 or 12 years. So there are a lot of disabled people. See like this. So in Casu farm they have used endosulfan for about 10 years. The symptoms started, like this. Blood, liver, skin. The ill effect of one pesticide. So we are using a lot of pesticides in our agriculture. The ill effect of endosulfan, one chemical. Now it's banned worldwide. Recently, about 6 months back. What United Nations says, the solution lies in supporting small-scale farmers. We won't solve hunger and stop climate change with industrial farming in large plantation and large input farming. Knowledge and experimentation of smallholders should be used for rural development. Oliver D. Scotter, Special Rapporteurs, United Nations. So the world in 2050 by FAO, Food and Agricultural Organization of United Nations, population is going to reach about 9.2 billion, plus 33%. So cereal demand goes to 3.4 billion tons. Greenhouse gases, nowadays greenhouse gases is major problem, 160%. So global warming goes to 4 degrees. So arable land per capita minus 24. So in everything goes down. Crop land productivity is minus 8%. Plant diversity minus 33%. There is no forest at all. Agricultural water says, I told you, regarding my example of my farm, there will be no groundwater for agriculture and as well as for drinking purpose also in future days. So urban population goes to plus 70%. So crop yield in Asia minus 30%. Crop yield in Africa minus 35%. I don't know the other continents. See, this is the major threat we are going to face in future days. So all the problems is reached irreparable. So that's why what I did since from 23 years, actually I am practicing natural farming. I have invited several scientists to discuss, to give their reports, the merits and demerits of natural farming. Dr. Rame Gowda is the Vice Chancellor. Dr. Deshpande, Director for Institute for Social Economics, there is an agriculture economist. Dr. Ravi Shankar, Principal Scientist and Head, IHR Bangalore. So regarding food production is concerned, Dr. Kailash Murthy, I have invited so many scientists to discuss the natural farming merits and demerits, from food production to global warming. See, they're all scientists. They have visited my farm, they have made documentation, they have studied it thoroughly. So research finding from various institutions, natural farming makes soil fertile and rich in microbial diversity, helps natural resources conservation, mitigation of global warming. Dr. Nandini, Department of Environment Science, Bangalore University. Plant or healthy and productive, pest and disease level in the threshold level. Dr. Ravi Shankar and others from ICR. Research finding, okay, all the species are grown in harmony with each other. There is a kind of symbiotic relationship as observed. In the natural farming, 300 species of plants are found as in forest ecosystem. Dr. Ramesh, University of Agriculture Science, Department of Forestry, Ponampete. It checks soil erosion and water evaporation, which in turn increase soil fertility and improves groundwater. The Principal Watershed Development Training Center, Mysore. In the economic front, the cost of cultivation is reduced to negligible. Thus, this also reduced the farmers' dependency on the market and relieves the farmers from the requirement of large cash input, and in turn benefits consumers more with healthy and low price food. Dr. Deshpande, Director, Institute for Social and Economic Change, Bangalore. Natural farming helps to improve plant diversity, which consists of various useful rare medicinal plants which can be used to cure several diseases and can use as food. So, in my farm, there are about 300 type different unwanted. For me, it's unwanted. Its nature is wanted. Okay. So, about 50% we can use as a food for greens. Naturally grown food are good in taste, keeping quality, nutrition, and non-toxicity. CFTRI. Sivanandappa, Deputy Director, Central Food, CFTRI, Mysore. See, this is the soil fertility before and after. So, soil fertility before natural farming and after natural farming. Soil fertility keeps on increasing year by year. It sinks carbon. So, physical parameter of soil samples report by Department of Environment Studies, Bangalore University. See, this is the samples. See, natural farming, soil fertility, NPK and water holding capacity keeps on increasing. See, pH is 7.3, that's 8.2. EC, organic carbon 2%, chemical farming 0.77. When I was doing chemical farming, organic carbon is 0.77. So when I was doing natural farming, organic carbon 0.2%. So nitrogen per kg 268 and 110. Phosphorus kg 52 and 65. Potassium 179, 100. Okay, water holding capacity 54%. So chemical farming, when I was doing in Sindha 84, that's 33%. So everything keeps on increasing. See, suppose if we press the metal rod, it percolates about 3 feet in one press. Such a porosity I am having because the plant and microbes, they have created porosities. Even if I get heavy rains like South Canara, what all the rain we are getting, it percolates. Water holding capacity, soil groundwater table increases like anything. So soil microbes, okay. See my farm, previously my missus, myself and my labor. My silk, this is a silk mulberry leaf, a drumstick and arcanut. See, can you tell me what is the production cost of this banana bunch? Only water. So big, with zero input. So production cost not even 10 rupees. Paddy I tried for 5 years in a small area because now I am facing a lot of water problem. So that's why I left. See, 25 to 33 quintals per acre we can harvest in 1 acre of land. See, Arcanut is papaya. So I can sell my product cheaper. See, this is very interesting. See, mango flowering is there. The next year, this one is the powdery mildew. It's very difficult to control because if it is any changes in the climate, suppose if the cloudy weather comes in the month of January, automatically this plant's affected by this powdery mildew. It's one kind of a fungus. So what the plant will do, it will stop flowering if the clouds comes. So what all the flowers opened, it will dry. It will affected by disease. Then after dry weather comes, automatically again it blossoms. Such a defense mechanism is going on in my farm. So there is a lot of pests are there. See, we are using pesticides for even endosulfan we are using, monocrotophos we are using, the pupal tragedy, the 7 chemical we are using to control this pest. So if the pest population increases, automatically the production increases in my farm. See, mango. So last year total overall production in India, that's only 20%. This year only 30% because of climate change, ill effects of climate change. But in my farm also, the same thing going on without pesticides and without modern agriculture practices. I am also going to harvest only 30% this time. Those who are doing chemical farming also, they are getting only 30% crop production, even though they have used all sorts of modern technology. See, pepper is there, pulses is there, ham and orange. See, this is a drumstick. It's a vegetable. See, what all the mangoes I am growing, I am giving for school children free of cost and friends. So about 5 to 6 tons every year I am giving for school children to create awareness program among school children. So I am educating school children regarding environment issues. See, I will teach them how to handle snakes also. Because snakes are very friendly with us, but only the human beings are more dangerous with us. See, I am conducting mango feast for school children, so they can consume how much they can. Every year I am conducting. So I know how to handle snakes. I am very friendly with snakes. See, actually I am conserving total ecology. See, visitors from different countries. So actually I am conducting some seminars from what all the fund I am generating. Earnings, I am not getting any fund from anybody else. I am conducting some seminars to create awareness among farmers and scientists and even business class in my farm itself. So at the time of inauguration of my seminars, so they have to release the snakes to the garden. Not like lighting the lamp or like that. So they have to release the snakes to my farm. So pests are there. So sometimes the peacock comes and breeds. All the animals, they will come and they will breed and go. The ecology is 100% conserved. It's like a forest ecosystem. So what we have to do in future? See, we people are wasting maximum, about 40% of the food we are wasting after harvesting in the form of transportation and kitchen. Okay. Changing in agriculture system and food habits. We have to change our agriculture by force. Otherwise, it's very difficult to survive. So grow regionally and seasonal crops. You have to grow. We have to go according to region and season wise. We have to check population growth also. Adopt natural farming and natural food habits. We are forced to adapt. Conserve ecology, simple living, check urban population and proper utilization of human excretas. So this is nature. It's a food chain. So if it is break, the entire thing will collapse. I never knew that human beings are more intelligent, stronger, criminals. Because we are trying to destroy the entire ecology, Sorry. Thank you.